All right, so today we are going to dive deep into two-dimensional semantics, which has become, a pretty significant tool in philosophical semantics. You know, we often talk about possible world semantics.
Right.
And possible world semantics just uses a single single way the world could be to sort of figure out meaning.
Yeah.
But two-dimensional semantics is kind of like, what happens if we add in a second layer of possibility? And that's sort of the core idea behind 2D semantics. Is it's meant to give us a more nuanced, I guess, a more complete, a more full way to analyze meaning when we're trying to understand, how language works, how thought works, all of that.
Yeah, that's a great way to put it. The standard possible world semantics has been incredibly valuable, but this 2D semantics really opens up, I guess, a bigger space. It gives us more tools for looking at meaning. And yeah, it's kind of like adding depth. It allows us to capture distinctions that maybe you wouldn't be able to capture if you're only looking at things one-dimensionally.
Right, exactly.
And I think it really gets at how meaning might depend not just on how the world is, but how we think about it.
Yeah.
How we conceive of the world.
I see.
So, yeah.
That's really interesting. Okay, so if you're a philosopher, let's say, and you're diving into two-dimensional semantics, there are three really fundamental questions that you would have to grapple with. And these questions, they really drive the development of any kind of 2D semantic theory, I think.
Yeah.
So the first is like, what are these two dimensions of possible worlds? Like, what do they actually represent? I mean, are they different kinds of possibilities, or are they different roles that possibilities play in figuring out what things mean? And then the second question is, well, okay, so we've got these two dimensions of possible worlds. How do we set up the rules for assigning these two-dimensional semantic values to our expressions? Like, how do we actually, build up this 2D picture? How does that work? And then the third question, and I think this is maybe the most important one, is, well, how do these 2D semantic values actually help us understand what our words and sentences mean? What kind of new insights do they provide that maybe we wouldn't have had with a one-dimensional approach?
Yeah, I mean, those are definitely the key questions. And I think it's fascinating because the 2D framework itself it's really just a framework. It's a structure, it's formal. But it's the way that we interpret those two dimensions and the rules that we come up with for assigning semantic values. That's what really leads to all these different theories with different explanatory goals.
Yeah.
So there's a lot of space there for different approaches, I think.
And this framework, it's found a lot of different uses, places where it seems to be quite useful. Our sources highlight two main areas where 2D semantics has been really productive. So first is what we might call restricted cases, and this is dealing with things like indexicals, context-dependent terms, like I, here, now, that sort of thing, and also analyzing modal operators,
right.
Like actually necessarily. But then there's this more ambitious application, which is this idea of generalized 2D semantics. And this is really trying to get at something much, much deeper, I guess, which is the a priori aspects of meaning. So, those aspects of meaning that we can grasp just through reflection.
Right, yeah. So the earlier work in 2D semantics really was focused on trying to solve these specific puzzles in philosophy of language and logic, But when you get to the generalized approaches, they're really trying to deal with these, bigger, much broader questions about meaning itself. What is meaning? And in particular, this connection between meaning and what we can know without relying on experience, So it's really getting at some deep philosophical issues.
Yeah, exactly. And then there's one other approach we want to talk about, and that is Stalnaker's meta-semantic interpretation. And this is kind of a different lens on the whole 2D framework. So it's not really focused on literal meaning in the traditional sense. Instead, it's looking at how we manage to communicate. How we manage to communicate effectively, even when we don't have a full, perfect understanding of what our words mean, right? It's like those times where you're having a conversation and, you don't have this perfect common ground, you don't fully understand each other, but somehow you still manage to get the point across. So it's a different kind of approach, but it's interesting. It seems like this 2D tool is really adaptable. You can use it in all sorts of different philosophical inquiries.
Yeah, definitely. And Stalnaker's work, I think, is especially important for philosophers who are interested in pragmatics,
right?
Which is really about how language is used in real world situations, and it shows that you know, even if you're skeptical of this idea that 2D semantics reveals something about literal meaning, it can still be a really useful tool for understanding how we communicate, especially in these, messy real-life situations where things aren't always so clear-cut.
Okay, so let's start with these restricted applications. The initial push for 2D semantics, it seems like it really came from this attempt to better model context-sensitive expressions. So can you talk a bit about what were the limitations of standard possible world semantics when it came to dealing with things like indexicals, that sort of thing? What made people think, okay, maybe we need a 2D approach?
Sure. So one of the classic examples is the difference between a name like Barack Obama,
right,
and an indexical like I. So if you think about standard possible world semantics, the intention of Barack Obama, it's pretty straightforward. It picks out that individual, Barack Obama, in all the different possible worlds, right? It's what we call a rigid designator.
Right.
But now think about I. So imagine, Hillary Clinton says, I could have been president. Well, in that case, I refers to Hillary Clinton across all the different possible worlds. But if John McCain says the same thing,
right,
I refers to John McCain in all those worlds. And so, standard possible world semantics would treat those as the same kind of intention, a function that picks out the speaker.
Right.
But that doesn't capture the fact that the meaning of I is constant. It always means the speaker, but who it picks out,
right,
that changes depending on who's speaking.
Exactly.
Right. So there's this context dependence that the standard approach doesn't really handle very well.
Exactly. So the rule is the same, right? Refer to the speaker, but who that ends up being, that varies. It depends on the context, and I think this is where Kaplan's work comes in.
Yes.
Right. He really sort of brought this distinction between character and content to the forefront.
Right. Exactly. So Kaplan argued that we need to make this distinction to properly understand indexicals.
Okay.
So the character of an expression, that's kind of like the linguistic meaning or the rule that guides how we use it in a given context. But the content is the actual, proposition that's expressed.
Right.
Or the individual that's picked out.
Right.
In that particular context. And then the content is what has a modal profile.
Yeah.
It has a truth value or a reference or an extension across different possible worlds.
So the character of I is that rule, refers to the speaker of the context.
Right.
And then the content of an utterance of I, let's say, by Barack Obama. During his 2009 inauguration, right, the content there is Barack Obama.
Exactly.
And then he rigidly designates himself across, whatever possible worlds we might consider in that context.
Yeah.
But the context of use in this case, this centered world where Obama is the agent and it's that specific time and place,
right,
that determines the content. And then the circumstance of evaluation, the actual possible world that we're considering, that determines the extension of that content.
Right, exactly. And Kaplan formalized this notion of a context of use. And he talked about it as a centered world.
Okay.
So it's a possible world, but with a designated agent and time.
Okay.
And sometimes even a location.
Yeah.
And so the character takes that centered world as input.
Okay.
And gives you a content, which is a function from possible worlds to extensions.
I see. And we can sort of visualize all of this using these two-dimensional matrices.
Right.
So we can, we can array possible circumstances of evaluation, different ways the world could be along one axis, and then different contexts of utterance along the other.
Yeah.
And then each cell in the matrix, it tells us what the extension of the expression is.
Exactly. Yeah. And it's a great way to really see how context and modality interact.
Right. So for I, within a single row, let's say, that represents, Obama giving his inauguration speech, across all the different possible worlds, you're just going to see BO for Barack Obama.
Right.
But if you move down to a different row, let's say it's John McCain giving the speech, then you're going to see JM all the way across.
Exactly. So you can visually see how the reference changes,
right,
depending on the context.
Yeah.
But within a given context, it rigidly designates that same individual across all the worlds.
Right. And then if we contrast that with a definite description, like the inaugural speaker in 2009, then the 2D matrix, it looks quite different. So in this case, all the horizontal rows representing different contexts of use, those would all be the same.
Yeah.
Because that description, it's not context sensitive,
Right.
the way A is. However, within each row,
Right.
the extension would change across the different possible worlds.
Right. Okay.
So it would be Obama in worlds where he won, McCain in worlds where he won.
Yeah.
So it illustrates that it's not rigid,
Yeah.
right? It's context invariant, but it's non-rigid.
Right. Yeah. The description picks out whoever happens to have that role in each world.
Right. And then if we just consider a proper name like Barack Obama,
Yeah.
well, then the entire 2D matrix is just uniform. It's just BO all the way through.
Right.
Because on Kaplan's view, it's both context invariant and rigid.
Exactly.
So it always refers to the same person no matter what. Okay, so Kaplan, he also developed a logic of indexicals.
Right.
So how does that 2D framework play into how logical validity is defined in that system?
Well, so in Kaplan's logic, validity isn't just about truth in every possible world.
Yeah.
It's about truth in every possible context of use.
Okay.
So a sentence is logically valid if it's true, no matter who says it, where they say it, or when they say it.
Right.
So it's a really strong notion of logical truth.
Yeah.
And it really comes from the meaning of the indexicals themselves.
And that leads to this really, I guess, interesting idea that a sentence can be logically valid even if the proposition it expresses is only contingently true.
Right.
So the classic example here is I am here. So the rules for I and here,
Right.
they guarantee that no matter when that's uttered, it's going to be true in that context.
Exactly. Yeah. By definition, the speaker is at the location they're referring to as here.
Right. So if you were to construct a 2D matrix for I am here, the diagonal, so, the cells where the context of utterance and the circumstance of evaluation,
Right.
where those two match up,
Yeah.
those are all going to be true.
Yeah.
And this diagonal intention, I think Stolnaker later called it that,
Yeah.
is necessary. Right?
Yeah.
So that signifies a kind of logical validity. And in Kaplan's framework, it also signifies analyticity.
Yeah.
But the horizontal rows, which
Yeah.
represent the proposition expressed in a specific context,
Yeah.
Those might have both true and false values
Right.
in different circumstances of evaluation,
Yeah.
which just shows that the proposition itself is contingent.
Right. Exactly. Yeah. So, I mean, you could have easily been, somewhere else at that time.
Right,
Yeah.
exactly.
Yeah.
So it's really neat how that all works. Okay, so 2D semantics has also had a pretty big impact in modal logic itself, especially in how we deal with operators like actually and necessarily. So what were some of the limitations of standard modal logic, the kind with just the one possible world parameter that made people think, okay, maybe we need something more?
Well, so standard modal logic, it had trouble really capturing some of the intuitive aspects of necessity and possibility.
Okay.
Especially when it came to the actual world.
Okay.
Our world.
Right.
So, for example, think about this sentence. It's possible that everything that's actually red is shiny.
Okay.
So here, this word actually, it seems to be referring back to our world, the actual world.
Right.
Not to the world that we're considering as possible.
Right, exactly.
Right. And standard modal logic, it didn't have a way to really scope that reference correctly.
Right. So to address this, logicians, they introduced this actually operator. It's often symbolized as, and it's basically an instruction to evaluate the sentence that follows it.
Right.
With respect to a designated actual world.
Yeah.
Even if we're, embedded within other modal operators that are talking about different possible worlds.
Exactly. Yeah. So it lets us fix that reference
right
to what's true in our world. So in that example, we can say, there exists a possible world where everything that's red in the actual world is shiny in that world.
Right. So it gives you that power to really distinguish between something being, possibly red and possibly being something that is actually red.
Yeah, exactly.
But then there's this weird consequence, right?
Yeah.
So if a sentence S is true in the actual world, actually S is also going to be true. But then because the actually operator, it forces us to look at that same world no matter what. Actually, S ends up being true in all possible worlds.
Right. It becomes necessarily true.
Right. But that's kind of counterintuitive, right?
Yeah.
Because things about the actual world, like who won an election, those things seem contingent.
Right. They don't seem necessary.
Right, exactly.
Anyway. So to deal with that, Crossley and Humberstone, they introduced this fixedly operator.
Okay.
And the idea is that a sentence is fixedly actually true if it's true no matter which world we pick as the actual world.
Okay.
So you have this complex operator, fixedly actually, which is meant to capture this, stronger sense of necessity.
Right.
So we can say that, Obama actually won might be true.
Okay.
But it's not fixedly actually true.
Yeah.
Because if we had picked a different world as actual,
right,
that sentence would be false.
Okay.
Right.
And we can use these 2D matrices again to sort of visualize all of this.
Yeah.
So we've got possible worlds as our circumstances of evaluation, let's say, along one axis. And then we've got the same set of worlds as, the actual world along the other axis.
Yeah.
And then the truth value of a sentence with the actually operator in it, that depends on which world is designated as actual for that row.
Yeah. So for Obama actually won, the row where Obama's world is the actual world. That row will have true all the way across.
Oh, okay.
But if you look at the rows where, McCain won or Clinton won, those will have false all the way across.
Okay.
And then the diagonal of that matrix shows us the truth value when the world of evaluation and the world designated as actual,
right,
when those are the same.
Right.
And because that diagonal isn't all true, that shows us that it's contingent.
Right. Exactly. Okay. So this early work with modal logic, it also sort of showed that maybe we need something beyond a simple 2D framework, especially when you start dealing with, sentences that have nested modal operators,
right,
and really complex sentences, like the famous Titanic example, where you're talking about what's necessarily the case given what is actually the case.
Yeah, that's a good example, and I think that's a really crucial point for philosophers who are interested in the more formal details of all this.
Yeah.
Because while the 2D models they were a big step forward in handling actually, people started to realize that to really get the full expressive power, especially with multiple embeddings of modal and temporal operators, you might need a more intricate framework.
Right.
Maybe involving multiple indices or even sequences of indices.
Right.
So we got pretty complicated.
And this development in modal logic, it also had philosophical applications. And one of the main areas where this played out was in addressing Kripke's well-known puzzles about necessary a posteriori and contingent a priori truths.
Right. Yeah. So philosophers like Davies and Humberstone,
okay,
they argued that this distinction between the fixedly actually operator
right,
and the standard necessity operator, it could help explain how there might be these two different kinds of necessity.
Okay.
One that's really deep and robust, and then another that's kind of more superficial, tied to how our world happens to be.
Okay.
And so this distinction could help explain, how something like Obama actually won.
Right.
That might be necessary in a kind of superficial sense.
Right.
Within a model where that's how we've set things up.
Right.
But it still feels, contingent from this broader perspective.
Right. Yeah.
So it's a way of kind of resolving that tension.
And they also explored this idea that the actually operator, it could be helpful in analyzing descriptive names.
Yeah.
So things like Julius is the actual inventor of the zip.
Yeah.
And also natural kind terms like water is the actual chemical kind that
right.
So this offered a way to understand, why a statement like Julius invented the zip seems contingent, but yeah, we could know it a priori if we just stipulate that Julius refers to whoever actually invented it,
right,
without actually knowing who that was.
Yeah. And
then also why something like water H2O seems like a necessary truth that we can only know a posteriori,
right,
if we say that, water implicitly refers to whatever the actual chemical kind is that has these observable properties that we associate with water.
Yeah, and which we discover through science, through empirical investigation.
Right, exactly.
And although Davies and Humberstone themselves, they had some reservations about whether this approach could really solve all of Kripke's puzzles.
Right.
I think their work was really important because it showed how powerful this actually operator could be, and it really paved the way for this this more ambitious project of generalized 2D semantics,
Right.
which is really about applying this 2D framework to all kinds of expressions, not just indexicals and modal operators.
Right. So let's move on to generalized 2D semantics then.
Yeah.
And it seems like the main goal here is to, in some sense, rescue this traditional philosophical intuition
Yeah.
that we have a priori access to our own meanings.
Yeah.
And that's a really bold claim, it seems like.
It is, yeah.
Yeah.
It's a much bigger claim than just trying to model how indexicals work.
Right.
The traditional view, which goes way back, it was that to understand the meaning of a word meant that you implicitly grasped this criterion that determined its extension in any conceivable situation.
Right.
And this grasp, it had two functions.
Okay.
So first of all, it defines semantic competence.
Right.
So if you and I share the same meaning,
Right.
that means we're sharing this underlying criterion.
Okay.
And secondly, it determined reference.
Right.
So this criterion tells us what the word picks out in any possible world.
Okay.
And so the idea was that if this was right, then we could make our meanings explicit just by thinking about them.
Right.
Just by doing a priori conceptual analysis.
Right.
And this seemed really powerful because it suggested that we could discover necessary truths about the world just by thinking about our concepts.
Right.
But then, along came the semantic externalists.
Right.
And they had these really powerful arguments based on, names like Gödel and natural kind terms like water.
Right.
And they argued that a speaker doesn't need to have this unique identifying criterion, one that holds across all possible worlds,
Right.
to be able to use the name correctly,
Right.
and refer to the right person.
Right.
So, for example, with water and H2O, our concept of water, that predates our scientific discovery
Right.
of its chemical composition.
Right, exactly. So these externalist arguments, they really seem to undermine this whole idea that we have this a priori access to meaning.
Yeah.
And that conceptual analysis can reveal necessary truths.
Yeah, they really challenged that whole picture.
Right. So what did the proponents of generalized 2D semantics do? They weren't ready to give up entirely.
No, they still thought that there was something to this traditional idea.
Right.
And they saw the 2D framework, especially the way it handles indexicals.
Right.
And these rigidified descriptions.
Yep.
They saw that as a possible way to reconcile this tension
Okay.
between the internalist intuitions about a priori access
Right.
and the externalist observations about reference.
Okay.
So they thought, well, maybe there's a way to have both.
Right. And the strategy, the way I understand it, is that even for names, and natural kind terms, competent speakers, they have some kind of a priori access to a reference fixing criterion.
Right.
So some way of picking out the thing.
Yeah.
But they might not have a priori access to the full modal profile or the essence of that referent,
Right.
which is something that you might only discover, through empirical investigation.
Yeah.
So it's kind of like with the actual speaker as the character for I, right?
Right.
We understand that rule a priori,
Yeah.
but we don't know who the actual speaker is
Right.
until we're actually in a specific context.
Exactly. Yeah.
Yeah.
So that's the basic idea.
And there were a lot of key figures in this movement. So, you got David Lewis, Frank Jackson, David Chong, and they all argued that this generalized 2D framework, it could help us understand this a priori semantic understanding.
Yeah. And they thought maybe we could analyze our concepts in terms of these two dimensions.
Okay.
To capture both how we fix the reference initially,
Right.
which might be a priori,
Okay.
and then what that referent really turns out to be.
Okay.
Which often requires going out and investigating the world.
Right. And it's interesting, as our sources point out, that generalized 2D semantics, it was really driven by these big philosophical questions.
Mm-hmm.
It wasn't about trying to figure out the details of compositional semantics, like how these meanings combine to form larger meanings.